Hey guys, and welcome back. Today we're going to be broadening our view of how many solutions there can be. We have three options here: one, none, or infinite. So far, we've really just been focusing on one. When you guys find the value of the variable, you found the one solution. Well, there's actually different options here other than just one solution. We're going to solve equations in one variable using multiple steps, just like we have been throughout the last couple weeks. But our success criteria today is that we're going to do a little analyzation. Okay, we're going to analyze the structure of each side of an equation. So we're going to be looking for how an equation looks. That's going to help us draw conclusions. Okay, that's our second success criteria. Draw a conclusion based on what we see when a variable is eliminated. And then we're also going to test solutions to prove any conclusions. Okay, we're going to test those solutions to see why we could possibly have one, none, or infinitely many solutions. Okay, so the key idea here behind one solution is to actually find what the value of the variable is. It says a linear equation in one variable has one solution if only one value of the variable makes the equation true. So let's take this equation here that they give us, 57.9 minus 98.2y equals 303.4. Now, if you were to get rid of the addition or subtraction, which I see the 57.9 is being added to the negative 98.2y, they subtract it from each side. Okay, that's this negative 57.9 on each side of the equation, getting the 2 becomes 0. And then 303.4 minus 57.9 is 245.5. Then our last step, as we would usually do if this was our own equation, would be to divide by negative 98.2 on each side, getting y is equal to negative 2.5. Now that is one solution. Only negative 2.5, when plugged back into the original equation, will make it true. And you can check your solution by doing just that, by taking that negative 2.5, plugging it in for the y, and seeing that the equation is true. Now, not all the time will you be able to solve for the variable. Sometimes when you're trying to solve, the variables will cancel on both sides, and you're left to draw a conclusion based on what is left over. So for example, if we have no solution, a linear equation in one variable has no solution if no value of the variable makes the two sides of the equation equal. So for instance, in this equation, we have 3 times the quantity 2g plus 4 is equal to 6g plus 9. If you were to use the distributive property for that 3 on the left side, 3 times 2g is where the 6g is coming from, and then the 3 times the 4 is where the 12 is coming from. Now notice how you have a 6g and a 6g on both sides. They are of equal value, so you can't even follow the tip that I gave you guys about moving the smallest one, so it really wouldn't matter which one you moved. So let's say we moved this one over to this side. Well, it's positive 6g, so we have to subtract 6g from both sides. That's where they're inserting a negative 6g. But on both sides, positive 6g and negative 6g will become a 0, positive 6g and negative 6g will become a 0, which leaves you dropping down a positive 12 and a positive 9. Now, this end result, 12 equals 9. That is a false statement. Okay, 12 does definitely not equal 5. They are in two different spots on the number line. Because this is so, we draw the conclusion that there is no solution. Okay, so if you get the variables to cancel on both sides of an equation and you're left with a false statement, you are to conclude that no value for the variable will make this equation true. Now, in the opposite way, you can have infinitely many solutions. So take a look at the equation given here. 9 plus 4p minus 2 equals p plus 3p plus 7. We should always exercise good simplification skills first. So I see some like terms, that 9 and that negative 2, the p and the 3p, those are like terms. They can be put together. The 9 and the negative 2 is going to become the 7. And then the p and the 3p is where the 4p is going to come from. So now again, we want to move one of the variable terms, which I see a 4p and a 4p on each side of the equation. Let's say we're going to move this one over. It's positive 4p, so we have to subtract 4p from each side, which again we see on both sides the 4p canceling. 4p, positive 4p and negative 4p become 0. Again, positive 4p and negative 4p become 0, leaving the 7 to drop down and the 7 to drop down. So then we have 7 equals 7. That is a true statement. Okay, because 7 does equal 7, then we can draw the conclusion that there are infinitely many solutions, that any value of p is going to make this equation true. You can really pick any value. You can pick 50, you can pick negative 17. If you were to plug any value into the original equation, it's going to come out to be a true statement. And you can go ahead and test that. So let's take a look at the first example. Either we'll have to simplify or just look at the structure of what's going on here to determine if there is one solution, no solutions, or infinitely many solutions. Now, let's take a look at this first one over on the far left. 4 equals 9. 4 definitely does not equal 9. That is a false statement. Okay, so since there's no variable involved, that seems like what we would get at the end of trying to solve for an equation. That would be under no solution. So I'm going to put that example under no solution. Okay, the second expression we have here, I shouldn't say expression, equation, I have is x equals 2/5. Well, it's not saying that two numbers that are unequal are equal to each other, and it's also not saying that two numbers that are equal to each other. It actually is telling us exactly what the variable is equal to. So that is going to be one solution. X equals 2/5 is under one solution. The only number that it's saying x is equal to is 2/5. Now let's look at the third equation here. I see the exact same thing. 2j plus 7 is equal to 2j plus 7. That is actually structurally an infinite solution, okay? Because if we were to start solving by taking this 2j and moving it to the opposite side, we'd get 2j plus 7 is equal to 2j plus 7. And we would have to insert a negative 2j on both sides, which positive 2j and negative 2j would cancel on both sides, leaving 7 is equal to 7. Okay, that is a true statement, so that means that 2j plus 7 equals 2j plus 7 would be under the infinitely many solutions category. Okay, so really, you can actually stop if you see this type of structure, where you see that the left side is the same thing as the right side, especially if after you simplify, they become the same, then that means it's an infinitely many solution situation. So let's take a look at the fourth situation here, equation. Let's actually solve for h here. Let's see if we can. If we divide by 3 on both sides, we get h is equal to 4. Now, since the variable did not cancel and we found out what the one number h can equal is, that means there is one solution. So we're going to put that under the one solution category. Got a couple more here, 2 more in fact. I have 2 over 10 is equal to 0.02. Now, this is actually 2/10, and this one, the 2's place value is in the hundredths. So if I were to change this into a fraction, it would actually be 2 over 100, which is different than 2 over 10. Since they're saying 2/10 is the same as 2/100, which is not true. If we cut a pizza 10 ways and I gave you 2 slices, that would be much different if I cut a pizza 100 ways and only gave you 2 slices. So these are 2 different numbers. Since they are actually not equal to each other, that is a no solution. There's not going to be any variable that's going to be able to make 2/10 the same as 2/100. Last one I have here, they're in fractional form, so I'm going to simplify the one I can. 5/10 can be divided by 5 on both the numerator and the denominator. 5 divided by 5 is 1, and 10 divided by 5 is 2. So I actually have 1/2 equaling the same thing 1/2. So that does make sense. So I'm going to say that is under the infinitely many solutions category. 1/2 equaling 5/10 is in the infinitely many solutions. Okay, so we examined how after simplification or just the way that you're presented equations, how you can draw conclusions upon how many solutions there are in each one. Let's have you give this a try in your first U-try. All right, for this next U-try, I want you to try to A, write a linear equation in one variable that has no solution, and then B, write a linear equation in one variable that has infinitely many solutions. You can try to make the equations complex that's simplified to something like this, or you can write them as simple as you want them to. Just make sure that you're structurally creating something that is like, and we can go back to the example here, create something that is structurally like this equation right here, where you see the same thing on both sides, or you see this last number being different. That's going to create that no solution situation. Something that would solve to something that didn't make sense would be no solution, and something that would solve to something that did make sense would be infinitely many solutions. If you don't have the variables cancel on both sides, you're going to be creating something with one solution, so that's not something I'm looking for. Make sure you ask questions if you need it, if you need help structuring your equations, or you can also go back and rewatch this section. Give it a try. All right, in this next example, we're just given an equation and we're asked to solve it. We just want to keep in mind that there are other possibilities that there may not be a solution, or all answers could be solutions. So let's just start by using our good solving skills. If you need to, draw in that wall. And then 1, look for any distributive properties, look for any combining of like terms, or clearing out any fractions. So on the left side of the equation, I do see some like terms here. I see a W and a 5W that can go together. 1W plus 5W is going to be 6W. So we have 4 plus 6W on the left side. And then on the right side, I see a distributive property that 3 can multiply in to the 2W and the 1.6. 3 times 2W is 6W. And then 3 times 1.6, 3 times 1.6, that's going to be 4.8. So plus 4.8. Okay, so now I've got each of my equations' sides are simple. And I need to move the variables to be on the same side. I do see a 6W here and a 6W here. Again, they're both equal, so I'm just going to move this one over to that side. Start by scooting everything on the left over. Just rewrite the equation just as it is, and insert, since it's a positive 6W, I want to insert a negative 6W on both sides of the equation. Positive 6W and negative 6W will become a 0. And again, that will happen on the left side. And I'm left with 4 and 4.8. Now, 4 does not equal 4.8. Those are two different numbers. They lie slightly differently on the number line. So since we got something that is false, this is going to be no solutions. There is not going to be a W that will satisfy this equation. No solutions for this one. Okay, so you're going to get one in your U-try. It says solve 4 times the quantity n minus 2 minus 1 equaling 5n minus n plus 9. Solve that equation and tell me if there's one solution. If you do think there's one solution, tell me what that solution is. Or tell me if there's no solutions or infinitely many solutions. I want to do one more example where we exercise the same thing. We're going to be solving an equation, looking for one solution where we actually find the value of x, or if there's infinite or no solutions. And this time I've involved some decimals and fractions. So let's go ahead and go through our normal steps of solving, looking for any distributive properties or combining of any like terms, which I do see a distributive property on the left here. 0.25 times 4. 0.25 is actually 1/4, so a fourth of 4 is 1. So we just get x, 1x left over. And then a fourth of -2 is going to be 0.5. If you need to, type that in your calculator just to prove to yourself that 0.25 times -2 is -0.5, if you need to type that in, and that 0.25 times 4 is 1. Type it in your calculator if you don't believe me. And then on the right side, there's no distributive properties and there's no combining of like terms. Okay, so now I have an x on each side. I'm going to move this x over to that side. Scoot the left side over. And since it's a positive x, I'm going to insert a negative x on both sides. Positive x and negative x become 0 on both sides, canceling out, giving me -0.5 equals -1/2. Now, if you're not sure if those two are equal, just type in, to make this fraction into a decimal, 1 divided by 2 in your calculator, and it will give you, just dropping down the -1/2, drop down this negative as well. That's -0.5. That is true. -0.5 is equal to -0.5. So this one actually has infinite solutions. Now, when we say infinite solutions, that means any number will work. Okay, so let's just prove this to you. Let's test this equation. Pick any random number. Let's say we pick x is equal to 4. Okay, if I were to plug in x is equal to 4 into the original equation, I get 0.25 times 4 times 4 minus 2 is equal to 4 minus 1/2. Well, 4 times 4 is equal to 16. 16 minus 2 is equal to 14. Now I need to jump over to my calculator. I'm going to do 0.25 times 14. Here we go. I get 3.5. So here I get 3.5 is equal to, now 4 minus 1/2 is 3.5, which is the same as 3.5. So that actually worked. I picked a random number, 4, and it worked. Okay, now you don't have to write this down, but I can pick any other number as well. Let's say I pick x is equal to -7. Okay, let's plug that one in. 0.25 times 4 times -7 minus 2 is equal to -7 minus 1/2. Okay, so that's 0.25 times 4 times -7, that's -28, minus 2 is equal to -7 minus 1/2. 0.25 is equal to -28 minus 2 is -30. Again, I have to jump over to my calculator. 0.25 times -30. There we go, 0.25 times -30. That's equal to -7.5. Or -7.5. And -7 minus 1 more half is -7.5, which can also be expressed as -7.5. So that is also true. I just picked two random answers. Where before, in our previous lessons, if we solved incorrectly and got the wrong answer when we plugged it in, we got something that didn't make sense. I just randomly chose two answers, plugged them in, and both of them made sense. And this will keep happening. No matter what answer you choose, it's always going to end up working out. That is what we mean by infinite solutions. There literally is no end to the amount of x's that this equation is possible having. Whereas in the other type, no x can satisfy the equation. So go ahead and give this a try in your third and final U-try. All right, I got one last question for you just to see if you truly understand what was going on this lesson. It says a classmate solves the equation 8 plus 2 times the quantity 8r minus 2r is equal to 4 times the quantity 3r plus 2. She says r is equal to 0 is the only solution. Is she correct? And explain. So what I want you guys to do really here, don't even really regard what she says as r equals 0. I mean, think about it afterwards, after you solve, but take this equation, 8 plus 2 times 8r minus 2r equaling 4 times 3r plus 2. Actually solve that yourself. See if you can solve it without error, and then compare it to what she says r should equal, which is 0. And if you can figure out maybe where she went wrong along the way, maybe where she had the misconception of how r could equal 0, then explain that in your reasoning. Go ahead and give it a try. All right, that concludes our third lesson with solving equations in one variable using multiple steps. We analyzed today. We did a lot of analyzation about the structure of each side of an equation. We drew conclusions based on when the variable was eliminated, and we even tested solutions. We did that in example 3. We tested solutions so that we could see just how many solutions there were, or why we would say infinitely many versus none or one. So please go back and rewatch any sections you may not have understood, ask any questions you may have if you're confused on anything, and if you're ready to go, you may now proceed to the Google homework. Thank you. Have a great day.